Hello everybody and welcome to this webinar, how to design and prototype a coat hanger system with concepts in Shapr3D. My name is Claas Kuhnen. I'm a faculty of industrial design and head of interior design at Wayne State University in Detroit, Michigan, USA. This session will be very process and workflow focused, showing you a professional start to finish approach for product and prototype development. Okay, so let's get started. To give you a quick understanding of what I will show you all is, for example, how I work obviously with Shapr3D and create all these different variations, and how I use also Concepts, which is a two-dimensional sketching app, as an ideation tool. And then also how I later mix 2D and 3D ideation techniques to refine and develop further ideas. Okay, so with all that said, let's get started. So how do you come up with a good idea? Some people think an idea is very creative. Well, sometimes it is, but designing is not really necessarily an art, it's actually a process. And this is really what I would like to talk about in this webinar to demystify this a little bit. There are certain steps you can use that will then help you to come up really with interesting ideas and discoveries. One of the biggest problems, mistakes some people make at the beginning is they have one idea, the initial idea, they settle for it, and they just go with it. That actually is not good because you might prevent yourself from making interesting discoveries. And how do you make these discoveries? So let's talk about this. I have this coat hanger, which is okay, functional, but it's a little bit flimsy and it's definitely not really very visually appealing. And I wanted to have coat hangers which can be presented so they're functional and aesthetically also interesting. So I can show, for example, one of the prototypes I have here, or I have another finished prototype I will quickly show in the camera here. So how do you come up with these different ideas and develop them? So step number one, what you really want to do is understand your target. So the coat hanger. And as you can see here, I glued the coat hanger onto the wall, took a photo, ideally very precise, so no big perspective distortions. I zoomed in a little bit. Then I brought this coat hanger into Concepts and started scaling it to the correct dimension. I I measured some distances and then scaled this image correctly. And as you can see, I added more annotations to it. This really helps getting a good clarity about the proportions of your design, as well as doing mental notes too, because I don't have to every time remeasure or memorize that, for example, the opening where the rod will be in and the hook is actually 1 inch diameter. Okay, so with this first initial step done, now obviously then you go into ideation. Sketching, being able to draw really well, yes, that to a certain degree is also a little bit of an artistic skill, but you don't necessarily always need to be a very good drawer to make sense of sketches. So these drawings you see here first, they're kind of pretty basic, and they're also not very representative. And that's also totally fine, because the function and the purpose of these drawings you see here are nothing else than mental notes again. So I started, for example, here. First step, well, I would like to 3D print everything and then have wooden dowels in between. Here I took maybe a note about how I would like the hook and then the left and right arm connection be done with a sharp transition or rounded fillets. It's like where you start making these mental notes. Maybe a small variation. So I copy and pasted this drawing, moved it over, and I changed the hook a little bit. Also here I added a small wooden part into it. And then you can also see here for example, how I have all the different connections captured. For example, angled, or more like a kind of like a slot, or the plastic being bigger going over. Then I continued drawing. Here, let me zoom in a little bit. So the pipe in general, the plastic is bigger, maybe only where the wood inserts into the plastic is wider, or then maybe instead of rectangular, I made it round. So I kept playing, and then I realized, well, these laws actually don't really make much sense, because when you put a jacket that is kind of thin over it, these would press into the jacket. So I went back, kind of focusing on this type of an idea, the socket. No? And then maybe I continued here a little bit with different ideas. And you see the hook, which is kind of like a circle, I kept. And then I also went over to here have, for example, the hook flowing into the arm. So I think a little bit about aesthetics. And sometimes, now what can you do with a coat hanger? Well, you can put a jacket over it. But what about when you have a skirt you would like to hang, or a tank top? You need some sort of hooks. So I started making some initial rings that could be rotated. Very basic drawings, just so you don't forget stuff. And then maybe I continued here with drawing a sketch of the wood for the ring, or maybe there should just be a hole where I could 3D print something and put it in, or maybe I just make a cut in the wood so you have a depression right in there, no extra 3D printed needed. And then when I go a little bit to here, you can see how I further played with various ideas. So for example here, let's start with this one. So I decided now that the corners and the neck part is 3D printed, and then we have the wood part. And then here I did my first initial ideation about how maybe the plastic and the wood could be connected. Well, what about I have slots, so the wood slides into the plastic, and then via screws I fasten it. Visually, not necessarily very interesting. So what about bringing over a little bit of my experience in woodworking and decorative joinery? What about we make visible slots? So the wood does not necessarily slide into it, but here I hold this into the camera. I have more a slot where a wood piece then actually can go in. And knowing also how gravity works, you can see here that the slots are actually horizontal and not vertical, because when this is the coat hanger and this is the wooden piece, via gravity this works this way. So the wooden piece can't slide out. This way, if for example the coat hanger would be vertical, this could slide out. So it's a little bit of logical pre-thinking. Then also again here, well, with the slots, maybe I could glue this, or with a screw I fasten this too. Some more various ideas. Well, do we always need just a coat hanger? Can we just have some sort of a hook for other elements we want to hang? And then I went back to more ideation about various different systems to hang a skirt or tank top or something. A rectangular line, an arc. For example, this rectangular arc, then later I further developed into this idea of having a foot at the end that can then rotate, or like an arc that can rotate. So when they rotate it down, then it's for a coat hanger, and if they rotate it up, then I can hang something over it. So instead of having an additional piece to it, this is actually built into the end of the coat hanger. Also here again, a little study to make it round, capped perpendicular, capped at an angle, capped vertical. And maybe I don't really need something to rotate, because the more stuff you do, the more complicated something can get. So maybe just rounded arcs that go up a little bit. Just enough rotation to go up so that if I hang something in, it doesn't fall out. Okay, so then here a little bit more variation. So you really continue. Now you don't make just one or two sketches. You want to do a lot of sketches, and a lot of these sketches are pure junk. And that is totally fine, because the idea here is that through quantity, using quantity as a design strategy, at one point you will make a discovery. In all these years of my teaching, I always tell my students, if you don't really have an idea, either take a break or just do stuff. Turn your brain off, just work, make stuff. At one point you will find something. And this ideation strategy for me also personally always worked out in my private business. So here I started thinking about maybe some modularity, different, like one system, but then elements could even be interchanged. I'm thinking about later if this being brought on the market, how do we sell it? Just one piece or maybe multiple pieces, and like Lego, you can just plug them together as you need. So all this was basically pure ideation. And I didn't even touch any 3D yet. This might actually at this point a good moment to also explain why I really like Concepts as a sketching tool. I know some people ask about why I don't, for example, use Procreate, which is very popular, or Sketchbook Pro. And the main reason is, let me here go to there. So I can draw a line. There, it looks very nice. And if I now select this line, I can move this around, I can rotate it, I can make it really tiny, and I can scale it back up. And you noticed it never changes the resolution, always stays sharp. Well, maybe I would like to change the size. So I can change the stroke, I can change the color, I can even change the complete tool. So you start noticing that this is actually not pixel based, this is actually vector based. So everything you see there is a vector with just a texture put over it to make it look like it's pixel based, so hand drawn. And I can even smooth my hand drawing out. Like if you have a little shaky hand, then you can even this out. So really nice smooth lines, or curves actually. Also, what is very useful, now you have guides, line, arc, angle, etc. And this is the main reason why I use Shapr. Besides being vector, we also have dimensions. So if I need to make a line that is 3 inches long, or for example 14 inches long, there I draw this line, very good. I can pick this line, and how long is this line? Currently 12.4 inches. I want to make this 10 inches. You see, it's scaled. So this gives me actually the ability when I create sketches that these sketches are really to scale, because nothing is more annoying in my opinion when you do a really nice sketch and you like the form and then you go into CAD and it doesn't work. It's not the same. Which is why I really emphasize to my students like this ideation process of things being proportionally close, and then we still could do more drawings, as you can see here, but these are then based on actual dimensions. So what you see here is actually the layout of the coat hanger, and all these inner lines are representing various wooden doll dimensions you can find. Now I'm going to hold those into the camera for a moment. There they are. So I went to the local hardware store and bought actually a various amount of different wooden dolls, because even here with the dimension you pick, you don't want just to select one and just go with it, because maybe the one you picked is too thin, feels too flimsy, or the one you picked is too thick, is way too strong. And maybe it feels good in your hand, but then when you make a prototype, you realize the material is too thick. We have to thin it down. So on the right side, where my pen is, you see all the dimensions I measured in millimeter and inches. And then I made a 2-scale drawing now. So this is essentially now a coat hanger with the same size, but from the outside edge to the inside with a 1.1 inch wooden rod. Because I thought like, well, it's really nice and strong. And the problem I quickly noticed is actually that the corners left and right are pretty narrow, not really allowing me to easily hang, for example, dress pants through that opening. So that was not necessarily very good. And I quickly here already through this 2-scale drawing figured out this design does not actually work well. It has some issues. Also here you saw I did some more variations. I drew this first and then I saw kind of like, this is kind of like a silly transition, how actually the arc makes a transition into the line. First I thought this looks good, but it doesn't really look good. So copy and pasted just a variation of that arc and moved it to the side. Here then I started making a new version just with 0.87 wooden rod. Also to be more creative or continue my creativity, I created another hook, added it to it. Also here again, I did some more ideations about how can I actually manufacture it or prototype it. Now, a factory has different wooden tools than, for example, my model making shop. So I have to be very mindful about what I want to prototype or how I want to prototype it. And then I continued here a little bit, now with the 0.65 inch wooden rod. And then I zoom out a little bit. You can see how the design gets thinner and thinner. And the middle one seems to look pretty good. From this part, then I thought, well, these corners, what about I change them? And maybe I put this rod actually up. But then I didn't really like how the plastic rod or element touches the wooden rod. So I thought, well, if I just move everything down, then I can 3D model a connection to the plastic cap. So you see, this design, which later also I nearly settled onto, only developed because I did this sketch before and saw this corner problem. That is the way how I came up with this idea. I saw a problem, then I tried to find a solution to it. Okay, so before I continue, at this point now we talked a lot about concepts. Let's go to Shapr. You can see here I started with the vertical slots, then I made the slots horizontal. I also changed a little bit the proportions. In the first slot horizontal, the slots are kind of short. Then the slot horizontal print, the slots are longer. I thought about stability. Then I continued also playing a little bit with the different orientations. Do all slots are horizontal or vertical? And vertical we canceled out already. But what about like here in this asymmetry version, the lower one is horizontal and then the left and right arm, they are actually angled 45 degrees, but asymmetrical to each other to make it simply more visually interesting. And I just made a copy of a file and then continued adjusting the various designs. I skipped this one part, but I just wanted to show this too. So let me go to here and there, and let's turn all this stuff off. So here I made a screenshot in Concepts and then I brought it into Shapr. I'm here in 10 millimeters. I was before in inches because in Concepts I work in inches. And then This line is exactly, I think, 1 inch. I drew in Concepts 1 line. Sorry, in Shapr I drew 1 line, 1 inch, and then I needed to scale that image till it fit actually my Shapr line. And then this way I brought in a JPEG image being perfectly to scale into Concepts. Concepts itself also has the ability, when I go to export this as a DXF, but then you only have lines. And actually I wanted to see also the colors. And when I zoom in, now you can see this line gets thicker and thinner. So I could quickly show you how this process works. Maybe let's select this one. So snap and measure, very good. Then I would like to draw a line. I bring this one to there, bring this, no, don't draw a line. Bring this one to here, 6 inches, okay, and then I draw a line. Turn this off and select the line and make sure that, for example, it really is 6 inches, very good. Then I can select all this, and what I have selected, I think now I can export or the screenshot. Okay, so I was just curious if that will work. Doesn't. Also, we make a screenshot. 100 dpi, 2700 by 2000 pixels. If I go 200, I have 5000, so it gets high. So 200 will be fine. Export, and I will save this to files and bring this to the Shapr webinar folder. This is untitled 4. Very good. Okay, so let's go back to here. I hide this for the moment. Go to add an image. Go to Shapr, there we are. There's that image, very good. So bring it to somewhere. I can try to center it. It's not really that important yet, so I just position it roughly. I draw myself a line, because this line now has to be 6 inches. Oh, I made a curve actually. Zoop, there. Okay, so now I have a reference. Now I can go back, go to move. I bring actually this maybe to there. There we are. And then I scale this till the left line hits it. Okay. Very good. So this image is pretty close to scale, and now I can position it where I need it. Obviously, when I zoom in, things get a little bit more blurry, but that's fine. Now you could say, well, why don't you just import the DXF? Well, the thing what I noticed also with product design, I prefer drawing my own curves, because then I know they're clean, which is why in general I try to actually work with images and rather create myself some high-res images, and then I then I sketch my own sketch, because then I know it's clean, it's flawless, and when I start modeling, I won't have any surprises. Okay, so this basically explains also how I got the Shaprs, the concept stuff over into Shapr. Let's go back maybe to this part. So here, slot as symmetry version 3, I did some variations. You see the main difference is just the neck or the hook. So I just made a copy of asymmetry version 2 and just put a new hook in. And then I thought, well, what happens now when instead of here, I hold this in, having this corner part, I will actually print myself kind of like this part. So that when I hang something here it can hang on it, and the slot is asymmetrical. But maybe I don't necessarily want to create this, this cut you see there. So I have, like here in slot 5, everything angled up a little bit. And as you can see, I just continued and continued this display, various versions over versions over versions, and making copies and again making versions. And that is really the way how also in CAD you want to use it. Like in Shapr, it's not you have one idea and you start right into it. You actually still, and that's the beauty of CAD, like in Concepts, I can make copies in 2D, and in Shapr I can make copies in 3D. Because I have so many ideas or variations, I felt it's easier also to have various files than actually various models inside one file. And once, for example, you kind of like settled on a model or a design and you're ready to 3D print, then you can also prep your designs the way so that you can shoot out various print versions. So let me at this point now cover a little bit 3D printing and also show you how I use Shapr here. So I have various folders. For example, a folder for the raw model. You can see the biggest difference is the hook and the top arc aren't joined. Also, how are here those? Yeah, so they have a connection there. That's kind of like one of the thoughts I had to do. But then again, that would mean I have a wooden lathe, so I can actually cut or remove the wood material to create these pins, which I do not have. So I needed to simplify this a little bit. So I made a copy, moved everything to the side. So I have, for example, here my prefabrication model. So what I mean with prefab, now it's not really a prototype like what I would send out to a company to do. This is a simplified model, so I can actually create this in my own woodshop. And as you can see, the ends are flush. So I would create simply some butt joints. And let me now hold actually the prototype into the camera so you can see it. So there it is. There's now the printed prototype with these butt joints. And everything is held in place, as you can see currently, just with some masking tape or scotch tape. And this is a very flimsy model. But again, this is only meant for, now I have a 2-scale physical model. I can touch it. I can feel if I like the material thickness. So this is actually pretty good. To print this efficiently on a 3D printer, I will go into this and what 3D printer to use too. So in Shapr, you have a solid model, but if you want to print it, you want on each side have a really nice smooth printing surface. And if you print everything as a solid part, the printing machine has to create what's called a support structure. Because layer by layer, the model will be printed, and because this is art, there's an overhang, it needs to have this support structure. And if I hold this corner here into the camera, you can see this surface being a little bit rough, and also here this surface is actually not as good as this top surface, which did not have any support structure on it. That's the reason why I printed these two parts as halves, and also why in Concepts I actually slice these models. So I print one side and the other side, and then with a little bit of super glue you just simply glue them together, and then you have a solid piece again where the inside, the top and the bottom surface have exactly the same beautiful 3D printed structure. What's actually really nice about 3D printing, in this case here, I hope you can see this in the camera, the hook actually gets thinner, and then you can get these tongues or cathedrals, which makes it look like this is made out of wood, so it feels like wood grain. So you can even simulate maybe or play with the printing structure as, I don't want to say decorative element, but maybe, yeah, it kind of is a decorative element. Or what I mean, you can see this as imperfection, or you can see this as a structural detail. So after I made this prototype, then I went to here and, oh, no, don't do this. Thought about, well, I can also obviously print these as shells, but then screw this together. So here this is just two halves which can be glued together, and these are two halves where I put some screws into. So they are hollow. It has a little bit more of empty space in it. There's some support, this gridded stuff. The support actually I leave because it is nice and strong. And I included also those channels for the screw. So here you see they just go to the body, and then here on top I have the holes and even a depression created for a basic screw. I was just looking when I made this prototype what type of screws I have. This was nice, but unfortunately this screw was too long. It would stick through. This long has a wider head, but it wasn't as long, so I could screw this in there. With a caliper, I measured the diameter of the threading, and then I made the plastic a little bit smaller. So when I screw this in, the threading of the screw would actually eat into the plastic. So you don't really have to create threading inside your plastic model. We can just, with the screw, cut right into it. So it's self-tapping, if you want to call it that way. Okay. So that a little bit about the 3D printing. Again, I have these two parts. People were curious about how I created also kind of like these elements. So I'm quickly going to demonstrate to you this process too. I have one file prepped here. So there you see the two sides, and let me show you how I created this stuff. Okay, because Shapr has actually really terrific tools for that. So this is hollow, very good. Sorry, it's solid. So I will make a copy of this and just move it to the side. Very good. There, and I think I have a slicer. Where's my slicer sketch? There it is. This I will extrude a little bit, and this block is positioned at the center. There, very good. And then I will use this to remove actually half of it. But before I do this, I want to make a copy of this, and it should be at the same position. Copy, I aligned also the widget, move it up, move it back, exactly 0. Now I have a copy there. So now subtract this one minus this one. Oops, see, the tool is gone. Let's do this one more time. Subtract from you, please remove this block, but keep the original. Very nice. Now I need to figure out where is actually this other element. Oh, they're inside this folder there. Okay, so this one. Okay, very good. There. And then I will use intersect. So the volume of these two objects intersecting each other. And this one here, I will, with my finger, select and then drag out, bring it to there and hide it. Very good. We can then shell this. Now the shelling, that's actually important. What type of 3D printer you use? I use for this prototyping LaSBot with the Morse extruder, which prints very wide and kind of thick layers, which makes kind of coarse prints, but they are done in a fraction of a time. That one already takes 45 minutes. If we would print this fine, we're looking at multiple hours. And you don't want to spend one day printing one coat hanger. And for prototyping, this is perfectly fine. When this is 1.2 millimeter print width, then the layer thickness should be equal, double, or triple, or 4 times, but not like 2.5, because the printer has to just go along the lines. So 1.2 multiplied by 2 is 2.4 millimeters. Okay, so that looks pretty good. So that's now the material thickness for the shell. Now I would like to create the threading for it. I can draw a line, and I draw here a line, and I will hide this body. You see, by drawing a line to the edge, it actually copied this edge in. That was very useful. Maybe here I go to the midpoint, I go to there. On purpose, I move this to there. So what I'm doing here is U and U be perpendicular, U and U be tangent. And then I want to find the midpoint. These two lines, they should be equal. Now this point is exactly at the center. Very good. I could also have drawn one line, two. There are so many different ways how you could do this. Then I draw a circle. This center point I move to here. Select this one, maybe 2 millimeters. Then I will create an offset, 2.4 millimeters. Again, following exactly the same printing nozzle thickness. Then we can show this. We're pretty close already. U and U. I move down. And fortunately, you can see that it eats into the shell, but it does not cut through. So I can say join, and now I have created this version where the socket is added to it. Now for stability reason, and for 3D printing can be a little bit flimsy, this one I made the walls extra thick, so they won't break off. I can, however, in addition, add a little bit extra material. There. So these rings I want to lock so they don't move. Perpendicular, that's very good. So U and U should be 1.2 millimeters. This actually defines in how long this line is, which means I can select these two and say equal. See that? This one you changed. Okay. This should be 2. When this is 2, then this should be 4.4. Okay, good. Equal. There, you see how it actually all snaps together. Equal. And that even solves the position. So these lines are all perfectly tangent right now. So with that stuff done, now I can select these two areas too and push this down. New body, not new body, join, and 7.2, 8. Let's look at the bottom. Yeah. No, ha 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 ha. See there, they stick through. 7.5. Okay, see, that doesn't work. But I will do something like this. Make a small one, very good. And now we can use the replace face and say this face replace with this face, and actually it will flow over it. There, very good. Now, for the other side, so I will repeat the shelling. .4, very good. Then I will also here do my join, so union, but now I need to cut a hole, so here I cut through, see I pushed it through it, very good. And I can, if I want, where is the sketch? The sketch is down here, hide it. I could later even go ahead and say this maybe should be 5. This should be, instead of 2, maybe should be 1.9 millimeters. So everything can via direct modeling adjusted afterwards. Very good. To create now this space for the camera, to cut this one out, what I have to, not the camera, for the screw, what I have to do now is I need to create a cutout there. So also there, Shapr has all the tools we need. If we go add, construction, and I will use through a cylinder, click this, click OK. There's, I have an axis line, add construction plane, through edge at an angle. This is actually the horizontal version, so this is 0, very good. Then I can select this construction plane with my finger, I double tap it, turn on the cut section view, very good. Turn my axes off, or yeah, and then I will draw, actually this axis I will show, I will draw another line, and it snaps actually to this axis and makes a copy. There you see it. I'll bring this down, connect, bring this to there. Do my alignments. This should be perpendicular. This is perpendicular, very good. I know this should be 4 millimeters. And then we have to measure how deep, for example, is the screw head. And bring this up to there. Bring this up to there. So 3 millimeters, for example, is the screw head. And you see that it doesn't cut on top. So we can, if we want, lock this point. So this is the lower area, and then we increase here a little bit of material, or a bit generous, do a revolve of this face along this line. There, I turn this cut section off now. So there you see there's this pin, and then this pin I will remove. There, that's the way how I did it. So very simple. Okay, goodie. So let's go back. I did obviously a lot of 3D printing and some prototyping, but then you go back actually to your sketching too. So let's take a look at this. So here I created some mental notes how the stuff actually should be built. So maybe here just a little bit of a notch for the plastic part to go in, so I could glue this, but maybe this is not strong enough. So what about I drill a hole into the wood, 3D print a hole into the plastic, and then via a threaded rod we can just rotate it in and maybe with some glue seal it or fix it. I don't have that particular drill because I really need to drill perfect perpendicular or actually parallel lines to the wooden dowel. So I decided now here my prototyping to go more with the screws and just butt joints. So I document everything, and after then I made also this prototype here, kind of like with these tiny pins or motors and tension that go into the plastic. They still can kind of rotate, and I thought, well, if we use some dovetail idea, we can cut actually 3D print joints where when we slide it in, it can't really move out because the angular orientation of the sides will prevent the wooden parts to simply move out. They only can slide in or out one direction. But this really needs, and again, you need to have a precision and a rig to cut all these elements perfectly. For the prototyping process, I didn't do it. But I hope this way, as you can see, it shows you how I documented everything, how I started from the initial taking a photo, creating some sketches, creating more representational sketches, going over into Shapr, creating all these different ideation models, making screenshots, going back to concepts, documenting the different parts. And then the last piece, I thought then, okay, let's do a design family. So I settled on a configuration, a material thickness, one last ideation, the same idea. These are the purposes I identified for pants, normal coat hanger, for skirts, and then different hat variations. And after I'm done here, I made this version, and then this is now the step then when I came up with the idea of the dovetails. Okay, so we're kind of getting close to the end. I would like to show you now also how the 3D printing works. So let me find a good file. Yeah, I go to here and I turn all this off. I go to the prefab, turn this off. So there are all my individual elements I want to 3D print. You can export everything all at once or one by one. One by one then would be you just show the file you want to export. If you want to export all at once, you show them. Then you go to export. For 3D printing, we go to 3D print. You have here a slider for the resolution. You want it, to be honest, on high. We can include all the hidden elements, which we don't want. And what's really nice, save each first level item in a separate file. We can even there have separate elements. I personally really prefer going simply one by one. Then I can name everything correctly. So I go continue, export STL, and go to share, go to save to files, webinar, and then I can say socket, print. This is actually kind of like the hook, and click done, and then it exports it. So pretty simple. This is also the same process when you want to export something for manufacturing or small scale batch production. You would not really send them a 3D print. You would send them actually then a CAD 3D model, and Step or iGES are very popular. So you go to Step and you see here the dialog is pretty much the same. I will go in detail into the Step export too. So I will now switch to the desktop and show you there actually Cura. So here you see Cura Lusbot. So when you buy a Lusbot, this 3D printer, they have their modified Cura version. This is now, as you can see, the Lusbot with the TAS 6 more extruder installed. And there's one thing that's really important for you to keep in mind, and that is in Shapr when you export and what dimension system you export when you go for STL, because mesh models don't have the scale built in. So I have here a millimeter and a centimeter version. So I drag in the millimeter version, and you see this looks good. I drag in the centimeter version, and where's it? Where's the centimeter version? There, and there you can see it is tiny. Oh, there's the other one. So when we now would also export an STL model in meters, it would be too tiny. The program would tell you something is wrong. So millimeters is the dimension system you want to use. For those who are not familiar with 3D printing, so you see the hook is not upside down, it's vertical, and you see what's red, that's called an overhang. That the 3D printer can't really print. I need support. Generate support, I can turn on here. And you need the support, otherwise up here when the printer prints, the plastic would just fall down. You don't really see the support right now, but when we go to layer view, hold on 1 second. There, everything that's blue, that is the support that can be removed. I have a lot of support here, also inside, that's not really ideal. So in my case, I will actually rotate this. I go to rotate there, go 90 degrees. Very good. The software will slice the model and then create these layers again. And there you see we have minimal amount of support. When you see that structure, what you see there right now, that is also what you can see now in the camera. There's the gridded part, and there's that little bit of support left and right. And even in the first layer, if I zoom in, you see the model there starts already. What's red is actually the outside shell. And even inside, you see the yellow, that is actually a structure the 3D printing software creates for you to strengthen it out. That's called the infill. If we increase more infill, this actually, give me 1 second, you should see more. There, it's much stiffer, but it might be overkill, it's too strong. And then also you have various layer thicknesses, 0.5, 6, 9. So with this actually you can create various layer thicknesses. The higher the layer, the faster you can print. So this is 1 hour, and with high speed, so 9mm material thickness, it's slicing. See, we saved 20 minutes. That's quite a lot actually. Okay, so that actually for the 3D printing. Let's go back maybe to the iPad, and I show you the stuff for the 3D printers and then the manufacturing. So for 3D printers, again, the one I use is actually called the Lasbot. This is actually the Task 6 more extruder and a chew it. You see it has one material. In the webinar, somebody asked about the support structure. How do I remove this? Yes, I have to just break it off. If you print just with one printing head, or you can buy a printing head that prints with 2 materials. And then you can even, instead of using a build material, you can use a support material. In this case, do you see that translucent one? That can be dissolved, so you wash it away. Obviously, this is more meant for finer prints, so the prints will take a little bit longer because it doesn't use this big nozzle, but you will end up actually with less de-support. In particular here in this, that's kind of genius, in these small details, the support can be put in and later washed out, so you don't have to use a plier to get it out. Now, after this initial hand prototyping is done, this is all more proof of concept. This is not something I can put on the market or something. You might want then to go to prototyping. So if you just type in Google small scale prototyping, Google will always autocorrect everything for you. You find a lot of prototyping services. I'm here in the US. So you can find services here, in particular also in Michigan or abroad. And there are various bureaus that have either high-end 3D printing machines, so they can make better 3D print prototypes, or even they go into injection molding. So then you can look for small-scale injection molding. For those who do not know what that is, this is a nice image. You see there the chair, that's plastic, and left and right, that's actually the mold that's being created out of metal, and then they shoot hot plastic into the mold, let it solidify, take the 2 molds apart, and then you have the solidified plastic, in this case a chair, and kind of like here in this case it is just a small propeller. Making these molds is pretty expensive, which is why you only do this once really the prototyping is really done. One person also asked about strength in calculation or testing. So this is again something you do with your in-house testing. You can 3D print these also solid. I printed those not solid to just save time and material. But this is more the first visual study test. Then I could 3D print this solid, then the prints will be harder, and then really try to get very close to the actual final result. And then, yeah, you just try to break it. And where it breaks or you see issues, you document it. For example, like I have it here, you take notes, and then you go back into concepts and adjust all the stuff here. Yeah, the pencil is here, don't worry, there it is. And then here you have your designs adjusted based on the stability or strength issues you saw through the prototyping. Then you can go to these websites and get a quote. And once you get a quote and they you want to go ahead and make a small batch production, now you would export this as step. Step basically is just the name for a CAD file, and essentially it will be this model, for example, just in a different format. That is very important in case a manufacturer might, for example, have to adjust the design a little bit. So with adjust, what I mean, let's say we take a look at this version on there. This has these slots. I need a pin version there. There's a pin version. Okay, so this is the wood. I remove there. Okay, let me turn the sketch off. So let's say through the injection molding, they think, well, the way how I designed this is maybe nice visually, but it's just not strong enough. So this dimension has to be changed. Then they could use the CAD model, and like I do here right now, they actually would remove it. So in case, let's say like in this case, I have excessive amount of plastic, and they would say, well, if you just go to 8 millimeters, these rings would still be strong enough. So they will do that adjustment for you, because you're not sitting there right where the factory is. Otherwise, they would tell you, well, you have to go back to your computer file and adjust it, and that can complicate the communication and slow everything down, which is something you don't necessarily really want. Okay, I think this pretty much summed now everything up. How to create a coat hanger using Concepts and Shapr3D, and demonstrating to you an in-house rapid prototyping process before then we can make a small sketch production. I hope this was informative. If you have any questions, please let us know. Bye bye.